Hi there. Hope you have a fantastic day today. This lesson, I will go through 2023 HSC paper with you. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Part A. Initially, the tank is empty. Water is poured into the tank at a constant rate of 2 kr cubic centimeters per second, where K is a positive constant. So we know the volume of the tank is given by this. While water flow into the tank and also drains out of the bottom, the rate of change of the volume of the water in the tank is given by this. So in another word, the inflow rates of change of the volume at the outflow rate of change of the volume add together will give us this. Okay, so keep that in mind for me. So part I, show that the dt is equal to K over pi h. So we already given dv dt. So that's what we got. And we know the volume is this. So we know that dh dt is equal to dh times dt. And we already given dv dt. So we can use dv here. Okay. So we have dv dt already. So we need to find dh dv. And we know that v, let me write this down, v is pi r h squared minus h power 3 over 3. So we differentiate this. So dv dh will give me pi, and then h squared would bring down to become 2rh minus, so 3h squared over 3. So this cancel out. So that will give me equal to, so I can take h out as well. So that is just same as pi h 2r minus h. Okay, that is dv dh. So let me just substitute in here. So that is equal to dh dv is, we just need to flip this. Okay, because we already found dv dh. So we just flip this. So that becomes 1 over pi h 2r minus h. Okay, that is dh dv. Okay, which is reciprocal of this. And now we times dv dt. And we have dv dt is this. So which is times k 2r minus h. So there you go. So now I just simplify this. Don't forget we bracket this. And this 2rh, 2rh, we can cancel out. So that will give me equal to, so 1 times k will give me k over pi h. So there you go. Part 2. Show that the tank is full when the water T is equal to pi r squared over 2k. So to find T, so when the water is full, so that means H is equal to R, right? So that is R here. The H when the water is full, so that is full tank. That is H is equal to capital R. Okay, so let me just note that down. So that means from H equals 0 because it's initially empty and it's go up all the way full of the tank. That means H is equal to R. So keep that in mind. So what I do, I have dh dt from part I. So dh dt equal k over pi h. So there you go. So what I do, I just separate these two functions here. So that is, so I just do cross multiply. So that become pi h dh is k dt. So I just integrate this, both sides, this, okay? So this means that we need to find the volume. So from 0 all the way to the top, that is h from 0 to r, okay? So that means from 0 to capital R. And then for t, we start 0 all the way to, so at a certain time, so we're not sure. So this is the time at capital T. Time is capital T. So from here to here. So now I just integrate this, okay? So integrate pi h will give me pi over 2 h squared. So this is from 0 to r, which is integrate k dt will give me kt. And the time is from 0 to capital T, okay? So I just substitute the value in. So when r is equal to h, or h equal to r, so that become pi over 2 capital R squared minus, when h is equal to 0, the whole thing becomes 0. Now on the right hand side, when t equal capital T, so that means equal kt. And minus when t equals 0, 0 times k is 0. So there you go. So this means that, let me rewrite this. Kt is equal to pi r squared over 2. Okay, that's what that meant. If I divide by k on both sides, so that means t is equal to pi r squared over 2k. So there you go. Let's check. Yep, pi r squared over 2k is the time. Pi r squared over 2k. So that is the time when the tank is full. Okay, keep that in mind. Part 3. The instant the tank is full, the water stops flowing into the tank, but continues to drain out of the hole at the bottom as before. Show that the tank takes 3 times as long to empty as it did to fill. So first of all, we need to find the rate of change of the water flowing out of the tank. And that is dV dt. Okay, keep that in mind. And we know the rate of change of the water flowing into the tank is this. And the total rate of change of the water flow in and flow out of the tank is this. So what we need to do is we just need to use this rate of change minus the rate of change of the inflow will give us the rate of change of the water flowing out of the tank first. Okay, so that is equal to, so that is k 2r minus h. So let me just double check. K 2r minus h. Then we minus the inflow rate of change of the water. So that minus 2kr. So remember, this is the sum of the rate of change of inflow and outflow of the water. And this one here is the rate of change of the inflows. So if we do this, we will get the rate of change of the water flowing out of the tank. Okay, keep that in mind. So let me expand this out. Give me 2kr minus kh and minus 2kr. That will give me, so these two we can cancel out. So that is negative kh. So that will give me dV dt. Don't forget, when the tank is full, there is no water flowing into the tank, only flowing out. Okay, so keep that in mind. That means initially when t is equal to 0, so that h is equal to r, because when the water is full, so this is h. So that means full of water. So r is h. H is equal r. And when it's empty, So this means that the h, it becomes 0. Okay. So that is, let me just write this down. So that is when t is equal to capital T, let's say TE, mean T for empty. Okay. T, that means at the time when T is empty. So that is, we already use T, capital T here. So we use TE, that is empty, when the tank is empty. Okay. So that is h is equal to 0. Don't forget, because h is initially is full. So h is R. So when time is start at that instant, and then when t is equal to T, so TE. Okay. So h is 0. That's when the tank is empty. So therefore, we have the rate of change of dV dt is negative k h. And h is the variable. So therefore, we need to use change rule. Find dV dt is equal to somehow equal dh dt. Okay. So let me start writing on here. So dV dt, we have dV here times dt. And we need dh because h is the variable. So dh. And we already found dV dh on previous part. So dV dh is here. Okay, dV dh is pi h 2r minus h. Let me just write this down. So that is pi h 2r minus h. And then we times by dh dt. So now equal to, so dV dt is equal to pi h 2r minus h times dh dt is equal to negative kh. So there you go. So if I divide by h on both sides, so that cancel out, and I times dt on both sides, so that will give me pi 2r minus h dh is equal to negative k dt. So now if I integrate both sides, integrate this, now for h is from the tank full all the way to empty. So that means from h is equal to r to 0. Okay. From the tank was full all the way to empty. So from capital R to 0. And for time, so t is start from 0 all the way to time t empty. Okay. We're not sure what t is, but just use symbol t empty. So we need to find out te. Okay. So now just evaluate this. So integrate the left hand side, become pi 2r, integrate this, become h because h is the variable respect to h. So integrate h, become a half of h squared. And then this is from r to 0. So integrate negative k respect to t, give me negative kt. And from 0 to te. So now we just evaluate both sides. So when h is equal to 0, so the whole thing becomes 0. And we minus when h is equal to r, so that becomes pi 2r times r become r squared minus a half h squared become r squared. So that is equal to when t is equal to capital T E, so that means negative k T E. And when t is 0, that means becomes 0. So there you go. So that will give me, so let me simplify it inside here. So 2 minus a half. So that means 4 minus 1 is 3. So 3 over 2 r squared. So that becomes negative pi 3 r squared over 2 is equal to negative k T E. And then I divide by negative 1 on both sides. So that becomes 3 pi r squared over 2 is equal to k T E. Now if I divide by K on both sides, so this means that TE is equal to 3 pi r squared over 2K. That is the same as 3 lots of pi r squared over 2K. And don't forget, pi r squared over 2K is T. So 3T. Let's double check pi r squared over 2K. So there you go. Pi r squared over 2K. So that is T. So there you go. So this means that it takes 3 times to empty the tank as to fill. So therefore, it takes 3 times. So there you go. And thank you so much for watching. Bye.